Hi students, today we are going to discuss another important topic in thermodynamics, that is Gibbs free energy. Gibbs free energy is a thermodynamic parameter. It gives the information whether the reaction is feasible or not, whether the process is spontaneous or not. So we will see what is Gibbs equation. Gibbs free energy is a TD parameter, thermodynamic parameter. It is a state function. It depends on initial and final state of the system. That's why Gibbs free energy is a state function. It is not a path function. Okay. It tells us whether the given reaction is feasible or not. And also second point is given process spontaneous or not. Okay, spontaneous reaction means the reaction takes place its own accord without using any external source. So feasible, nothing but the given reaction is possible or not. So by using this thermodynamic parameter Gibbs free energy, we can estimate easily. Okay, let us see. That is G is equal to H minus Ts. So H means Gibbs free energy, and enthalpy, heat quantity of the system, and temperature. S, that is already you know that S stands for entropy. So entropy can be defined as it is a randomness of the molecular system. H can be defined the total heat content of the system. So Gibbs free energy equation combines two laws, that is first law of thermodynamics and second law of thermodynamics. First law of thermodynamics gives energy conservation principle. Second law of thermodynamics gives entropy of the system, more randomness. So it is a Gibbs equation is a state function, so it can be written as G1 H1 minus T1 S1, that is for initial state, and G2 is equal to H2 T2 S2, and for final state. So delta G, change in Gibbs free energy, is equal to G2 minus G1. So this equation can be written as G2 minus G1 is equal to H2 minus H1 T2 minus S2 minus T1 S1. Okay, at constant temperature it can be written as delta G, change in Gibbs free energy, that is delta G. Here also delta H at constant temperature, so delta S. So this is the Gibbs free energy equation. So equation lo already we discussed, that is spontaneous and feasible. So ice melting is a spontaneous reaction. Rusting of iron is a spontaneous reaction, and freezing of water is a non-spontaneous reaction because it requires energy. Okay, so spontaneous, not these T reactions are spontaneous reactions, and that is freezing of water. Freezing of water is a non-spontaneous reaction, and charging a battery is also a non-spontaneous reactions. Spontaneous means automatically the reaction takes place its own accord without using any external source. These two reactions are best examples for non-spontaneous reactions. Mathematical equation of Gibbs free energy is delta G is equal to delta H minus T delta S. This is change in Gibbs free energy, change in enthalpy, change in entropy. For spontaneous conditions, delta is less than 0, that is spontaneous reaction. Delta G is greater than 0, that is non-spontaneous reaction. Delta G is equal to 0, that condition said that reversible reactions. So for spontaneous reactions, how the entropy and Gibbs values are, we will see. So delta S is equal to positive, delta G is equal to negative. That condition is favorable for spontaneous reactions. Okay, delta S is equal to negative, delta G is equal to positive. That is related to the non-spontaneous reactions. And delta S is equal to 0, delta G is equal to 0. That condition is related to the reversible reactions. So thank you. Please subscribe Concepts Chemistry with Dr. Shekunti Ravi Kumar YouTube channel for more videos. Thank you.